Okay, problem number 19. Actually, 19 through 22, the instructions are determine whether the expressions are equivalent. So sort of back to the same idea from the first few problems, 2, 3, 4, but this time we're just dealing with two algebraic expressions. Now, you'll see that they worked out number 19 for you, but they worked it out algebraically. They took this, they knew that you could get rid of the parentheses because it was all addition. And then they combined like terms, right? The 3 and the -2 became 1. Here on this side, they knew that you could just get rid of the parentheses. So they simplified, and these two, once they're simplified, are equivalent. But I want to remind you that that's just one way to do it. We can use the idea of multiple representations to check and see if they're the same by thinking about what their graphs look like. If these two are equivalent, then their graphs and their tables will be the same. The input will always be the same as the output. So if you're not wanting to go through all the algebra, there's a lot more room for mistakes there, then you can use the graphing calculator. And again, I only have the option of Desmos. So I'm going to use Desmos here at home. And I'm going to type that in. So the first one I'm going to type in is that 5x plus 3 in parentheses. And then it's plus 3x squared. And then minus 2. So this is the graph of that first expression right there. Now the second expression, 5x plus 1, and then plus 3x squared. Notice that as I graphed it, once the final expression came into play, so see before I typed the squared part, the two weren't the same, right? So before I typed it, the blue and the red were two different ones. They weren't equivalent. But once I finalized, the two became one. The red was on top of the blue. Now here's the thing. On the TI graphing calculators, it's harder to tell which is which. So one way to do that is to go to the table and look at the values to make sure that they're same. Now you know how to go to a table on the TI graphing calculator. Here you press settings and turn them both into tables. So here I'm going to press settings, turn this into a table as well. And if you notice, the values, when you use an input of -2, the output is 3. When you use an input of -1, the output in both cases is -1. So when the tables and the graphs, so this is a way to confirm that for sure the graphs are matching up and that you're not just missing the other one and it's off somewhere off the screen. So you can do these however you want. If you want to work these out algebraically and do the distributive property and see if the two come out to the same, you can do that. And that's actually a good thing to practice. But then you can confirm your results by putting them in the graphing calculator. Now, if you do these in the graphing calculator, then sketch what the graph looks like and say both of the graphs look the same. Or if you do it by using a table, then by putting it in the graphing calculator and looking at the table, then write out the table to show that you actually did the work to tell, yes, both their tables look like this, or both their graphs look like this, and that's how I know they're the same, or their graphs are different, and this is what the two graphs look like, so I know they're not equivalent.